Geometric probability. When we talk about probability, anytime we're talking about probability, we always have total on bottom with intended outcome on top. And this should never be over 100%. You can have 100%, but it should never be over 100%. Let's get into it. So if I have a segment, I want to know what's the probability if I choose a random spot that would land on BC. Again, your total is the whole segment, so that would be the length on bottom. And then the intended outcome would be on top. So I look at this problem, I'm first going to draw my division bar. So my total here, you could just count if you want to, is from F to J. So again, you could count from F to J, or else I could do this spot right here is 15. And 15 minus 4 would give me 11. That would give me my distance in between, or just count the spaces. So my 11 goes on bottom, and then my intended outcome, it says from G to H. So what's my length from G to H? So from 6 to 11. So I could also count, or 11 minus 6 is going to give me 5. So the probability would land on F or GH would be 5 out of 11. So use your segments to find the probability. So for this problem, we could draw a line segment. So we know that a commuter train goes every 25 minutes, so from 0 to 25. That's how often it runs. So what's the probability you'd have to wait for 10 minutes? So let's say that it goes from 1 to 15, because then I would have to wait for 10 minutes for the next one to arrive. So my total here is the total length, which is 25, and my favorable outcome is going to be 0 to 15, because if you arrive in between 0 to 15 minutes, you would definitely have to wait for at least 10 minutes. So my favorable outcome would be 15. And you should always reduce. This could be reduced to 3/5, because both of them can be reduced by 5. So I want you to try the next two by yourself. The first probability you should have gotten was 3/8. Now this is a little bit more tricky because no more than 25 minutes. So my favorable outcome would be from 25 to 40 on my total, because that's where I would not have to wait any longer than 25 minutes. So then I would look at this and I say, I have to take my total and subtract my 25, which would give me 15. So it would be 3/8. The second one, as you can see, I drew a line and I had to add up all my totals. So red light was 30 seconds, then I added 15 to that for my green light, and then 10 for that to my yellow light. That's how I got 55 on the bottom, my total. Total is always on bottom. And then my intended outcome, which is green, which is 15 seconds, that goes on top, and I should always reduce my fraction. Probability with area, shapes, shapes, shapes. Area of R over the area of N. Another way to think of this is your total. The large section is your total. The intended section that you're looking at, that's your outcome that you want to get to. So if I look at this next problem, a circle is inscribed. That just means the circle's inside of a square. And you pick a point at random. What's the probability it's going to lie in my shaded region? So this region right here. So you have to think, what should I do with this? Well, for sure I know my total is going to be my whole square. So I'm going to write that down first. And since this is a square, I know that base times height, or side length squared, is going to give me my total. So 25 is going to be from the 5 times 5. Now that's my square, so I'm going to write that down. I already found that out. I'm asking for the shaded region. So it's like cutting out the circle. So I have to figure out what is going to be the area of the circle. Now this side length right here is 5, so that means the diameter is 5. So in this case, my radius is going to be 5 divided by 2, that's squared times pi, and that will give me my area of my circle, which would be, if you put that into your calculator, 19.625. So now I want to take my total and I want to subtract the section that's not included in my probability. So I take 25 and minus my answer, and I get 5.375. So I'm going to write 5.375. Now, I do not want a fraction with a decimal. So what you could do here is somehow simplify it, or else you can change it into a percentage. So this would be 21.5% chance that if you pick a point, it would be in the shaded region. Right now, I want you to attempt this problem by yourself. Also realize that since this triangle is inscribed, that means the points are at the side lengths of the square. So that means this length right here is 5, and this length right here is 5. That's going to help you find the area of the triangle. Again, pause the video and attempt it by yourself. You should have gotten 50% here. So my total would be my 5 times 5. That's the area of my square. And then my area of my triangle would be base times height divided by 2. In this case, my base is the side length, and my height is this length. So both of those are 5, and I get 12.5. And I subtract them, and I get 12.5 again. So it's always your intended outcome out of your total. So that's 50%. So my last one, what's the probability it's going to land in the shaded region? Well, I see 3 circles. So how am I going to solve this first is I'm going to draw out the 3 circles, and I'm going to find the area of each first, and then trying to think through what should be the numbers I'm using. In my first circle, my R is going to be 8. In my second circle, my R is 4. In my last little circle, my R is 2. So right now you should pause the video. Remember, radius squared times pi is my area, and find the area of all 3 circles to the nearest hundredth. So now when I look at this, I have to think, okay, what numbers should I be using for my total? Well, if I look at this, my shape, my largest shape is always going to be my total. So this right here is my total. So this is what should be on the bottom of my fraction, 200.96. Now I'm looking just for the shaded region, so this section right here. If I look at that circle, it was the middle circle, but with this section cut out. I do not want that section. So that's this little circle. So I have to subtract that little circle from my medium circle. And you would get 37.68. Now this is the intended outcome, the shaded region, so that is going to go on top. And I do not want decimal fractions, so you should divide this out and get a percentage. And when you're rounding for percentages, you could have the answer as 18.75%, or else you could have it as 18.8% or 19%. As long as I can see your work, I'm okay with that. So by work, I mean this right here. Have a great day.